So what I have here is two graphite rods that are approximately 7 millimeters in diameter. I have two pieces of wire wrapped around them, and then they're going through this resistive load bank, which is 5 of these in-wall heaters. So cores of these heaters, which are designed for 240 volts, 6.3 amps, so the resistance is around 40 ohms. Once you've disconnected the fan, some of the thermal cutouts, so they can just daisy chain together like that. Going into one end of them, I have the live wire of 120 volts, GFI protected. It goes into this whole bank of these heaters that are in parallel, so its overall resistance is like 8 ohms. Coming out the other lead of the heater, let me see if I can find that. At the end is a wire connected to this electrode, this graphite electrode. The other end is connected to the neutral. So basically this is 120 volts in series with 8 ohms. The maximum current with these touching each other is going to be, right now it's unplugged, it's going to be about 15 amps. And then of course the voltage will be 0 then, but as it spreads out, as you draw an arc, it's going to be increase the voltage and decrease the amperage. And so now I'm going to show you what kind of arcing can happen at that voltage and current. We'll compare it later to the DC 80 volts with 10 amps maximum current running through 8 ohms. So very careful, I'm going to tap these together. Get maybe a millimeter of arc. If I tap it for long enough, the electrode will become hot. Now I can draw it out. Maybe 3 millimeters, maybe even 4 or 5 if I let it get hot enough for long enough. Basically, on average, if I just tap them, the arc's going to go out as soon as they're separated, because the AC voltage falls to 0 120 times per second, and each time that happens, the arc will extinguish. Now that's not always the case if I do this enough, just kind of grind them together. Eventually, will get hot enough that the electrodes stay hot and sustain heat and sustain a plasma even after everything else is disconnected. And then even when there's a zero crossing in the current, it's still going to have an arc that continues. So like here I can pull it out maybe 3 millimeters. Like I said, it's GFI protected, so my chances of being electrocuted are smaller. I've also made sure I'm insulated from this and have it so that there's no way I can see the arc directly with my eyes. So I'm not going to have eye injury. And as you can see, it can still arc even with that, but it just has to be exposed and heated up for a while, and then it's able to continue it. If you just tap them briefly, like a switch losing contact, if they're like this, and then pull it away, the arc's going to stop immediately. Now let's try it with 80 volts DC. This should be a continuous flow of electrical current, no interruption, no zero crossing for it to stop discharging and just cool off. And so that should arc right off the bat without any touching. Just one brief touch should bring it out and allow it to arc several millimeters. Let's see how that pans out. So now I have 3 18-volt nominal lithium batteries, which actually are fully charged. They have 20 volts, roughly. And that is being, the positive side of the batteries is going to the red lead, just like the neutral was before. And now the negative side is being fed to the live prong, the black prong of the plug. Just going over here, going through the 8-ohm load bank, and directly back after it's going to the 8 ohms, it's going to these graphite rods. So now you can see, last time I just briefly touched these, nothing really got hot, and pulled them away. The arc would extinguish itself because of the zero crossings. Now it extends a couple millimeters, whatever I do, pretty much. I have to pull it away a distance to make it stop. If I just have it maybe a millimeter or two away, it'll go like that till the battery's dead, until I pull it away too far. So I have a millimeter or two arc before I can even get half a millimeter without it needing to be pulled away. Keep in mind this is half the voltage and half the current. We're getting, this looks harder to switch. If you quickly pull it away, it's still going to have some serious arc damage. A switch probably won't be able to interrupt that, even if it was rated for the much higher current and voltage from the previous test. So now I have 4 batteries in series, a total of 82 volts open circuit voltage. Still have 8 ohms in series with it. Then I have the arc gap. Now I'm getting almost the same, without even letting the electrodes warm up, I'm almost getting the same arc. I'm getting 4 millimeters of arc with 10 amps of 80 volts. As I go out with 15 amps of 120 volts. The difference is now, if it just briefly touched, even if electrodes are cold, it's still arcing that much because there's no interruption to the arc. It's a continuous current flow. So there's nothing that would cause it to want to cool off and extinguish.